Today I will show a new feature in NMSLab 3.10, which is the build classifier in the blob tool. So we are going to build two classifiers. One classifier that can distinguish these three types of grain. And finally we will see a segmentation of this petri dish and see if they are classified correctly. And we are going to see a segmentation and classification of these kibbles. And there are 5 different kibbles. And finally we will see here the mixed one. So the kibbles here are, because they're visually very easy to see for the example in the video. And with this example we will show it working on a more realistic type of application. Okay, so I will set up and show you how to train the classifier. Okay, so let's acquire the samples of the kibbles. So I'll present each sample. And it's always good to save them, so I'll call this kibble A. Capture the next. Okay, I'll press select the arrange all images so you can see a bit better that we have the training set and the mixed. Okay, the next I'll do is segmentation of the objects, so they're separated from the background, and I'll just use the standard petri dish blue background blobs. The blobs is good for separating touching objects. I just go ahead and do this on all of them. It is not strictly necessary to do this, since I can define a custom segmentation or specify the segmentation in the blob tool. But right now I'm just showing the basic, starting from nothing. So the next we need to do is to create the classes we would like to classify to in the blob tool. So I open the blob tool, I go to the class manager, I right click and say new, and then I select cable A, cable B, cable C, cable D, cable E, and then I'll make an additional one called dirt. And the reason I make the dirt is because my segmentation is a bit rough. So if you look in the image, so I have to close class manager, there will most likely be something that's not supposed to be there. Like here, there is something here. So the next thing we'll do is to extract the blobs from the images, and since I've already made the classes, I can add the labels directly. So let's see how it works. Select the extract from image. Select first the A image. Then I don't specify a segmentation since I've already made a foreground segmentation. The foreground segmentation will be used. Then I specify a label and press apply. And I do this for all the images. Extract image, cable B, label B, apply. See. And we see here there are some small things that are not really the classes. They come from the rough segmentation. In a second I'll show you how to take care of them. Okay, so now we have all the extracted segmented blobs. So I just sort by area. I will say all these small ones. I could perhaps also include these, but I will not. I will remove the label and I will add the label dirt for these. Okay, now we'll train the classifier. So I'll first mark all the blobs that I want to train on, which in this case is everything. And then I'll press the build classifier. So what you see here is the confusion matrix for the automatically built classifier. And as everything is in the diagonal, everything is correct. So each row is the reference class and the columns are the predicted. So you can see there are 22 keyboard E, which is predicted as keyboard E. So I'll go ahead and save it. So now when it is saved, I will clear the blobs from my selection here. I will extract the blobs from the mixed, and I will not apply any label. So we have extracted the blobs, and I'll just right click somewhere and say classify using my kibble. I'll ask if I want to save the result. I'll say yes, just so you can see what is being saved. So it's going to be an Excel file. With the classes, the count of each type, the percentage of the object, the area, and the volume. So in this case, I should have made a segmentation that will remove the dirt. It's very easy, but I will not cover it in this video. Anyway, let's look at the prediction. I'll say sort by predicted class. Looks pretty good. Okay, now finally I will do the extraction and classification of the wheat samples. So I just start with cleaning up, actually closing the block tool, close all the images. So start by acquiring sample A, and as always I will save the images, arrange them for you to see. So I have opened the blob tool. I will create the classes. Grain A, grain B, grain C, and I will then extract them, but this time I will extract them using an MSI segmentation I have already defined that will remove dirt. So I'm simply limiting them on the size. So they need to be 1 millimeter times 2 millimeter. So with the training data, it's good. So I select all the objects, press build classifier, save it, call it grain 2, clear the blobs. I will extract from the next with no label. Then I right click, classify with our newly grain 2 classifier. I will not save this result. Let's sort by predicted, and it looks correct. So these classification can use together with the session tools, for instance, to measure the distribution between different the distribution of whatever you are measuring. So that's it for now. That's the new automatic classification build classifier tool.